Hey, everybody. My name's Newman, and you are with the Gimbalabs gang. We've got Harsha and Lewis here today, and it's a community code review. It's a Wednesday at 14:30 UTC. We do this each week where we go learn Aiken code line by line. And we have something special today. We are going to look at uh, the the Plutus NFT scripts from the mesh documentation and take a step back and try to get the whole picture of the application, which is this NFT vending machine. It's a part of the mesh documentation, and they've got all these resources, but we want to create a schematic, a visual schematic of what's going on in the transactions. And I think this is something that would be helpful to any blockchain builder, uh, not only to document the transactions and troubleshoot, but also to communicate it to others. Yeah. Harsha, Lewis, does that introduce us enough
Yeah.
to
We
what
can
we want to
jump
get
in.
into?
Do you want to share the screen of the
Yeah, let
whiteboard?
me yeah, let me share the screen, and I'm going to start with where I first saw this, and it led to being very um,
Holy bulls. Whoa.
confident. What do you see, Lewis? What do you see on the screen?
Hold on. Let me familiarize myself
Yeah,
a sec.
yeah.
If you-
It's the this is from the Asteria project, which we were gonna getting started in earnest exactly 1 year ago. It seems like Harsha.
Yep.
Imagine that. Imagine that. I definitely know more than I did last year around this time. That is for sure. But that being said, my conceptual knowledge of it is continually shifting. Um, when I saw this diagram, this guy right here, and I'm just actually going to copy this image. Um, I was like, oh, this is great, because then all of a sudden you can kind of see these are the inputs, this is the transaction, this gathered fuel, and these are the outputs. Um, it's interesting, and follow along with me here, Lewis. This
Mhm.
year, the same TX Pipe people put out this graphic about the purchase transaction for the tickets to Builderfest. And it's interesting. This is a little more public facing, less developer facing, because it just says funds, current state, this buyer ticket counter, um, and then buy ticket still in this same, and then ticket plus change, new state, and payment, um, which is also pretty good. Let's see if I can view this image. No, that's not right. Um, Ooh, I could take a well, no, we don't need this image because what we're going to work on is this um Fig Jam from Figma. And I can share this link with
So we'll
Lewis.
be going back and forth between the actual validators and the Figma, correct?
Yeah, back and forth to see where they fit, and then with a couple of reasons to sort of view it in a different way so that our understanding can change and help us troubleshoot. I guess that would be the way.
Correct.
Um, And then also the standard library, for instance, let me share this on the chat so Lewis can join us here at the Fig Jam. And let's see here. What is this? Oh, okay. Um, okay. This one, I don't like this one. I want to make
I give you my
this one.
email? Oh, just okay.
This is the graphic that I want. So this is our sort of original from TX Pipe, this gather fuel. And what we Well, should we just jump into it? What else? Maybe we should let's look at the mesh documentation. So here's the wonderful mesh. Um,
So,
they have,
Human, do you want to
yeah,
introduce what we are doing, like which validators we will be like implementing visually?
yes, yeah. Let me actually bring this up on my IDE. This is the one we were going through last week. Might take it a second for everything to jump in. Okay. Let me close all this down so we'll start from scratch. Okay, so here we go. Oh boy. Yeah. Now I've lost it. Hold on. Here it is. I think it was week 9. Yeah. Okay. It
Isn't it
was
Plutus
this.
NFT? Yeah, Aiken
Well,
workspace.
I think this is what we were going through last time. This validator. Well,
This,
no,
yeah,
no.
I thought
Here,
these three were the ones we are going to visualize today.
yeah, yeah. And remember, we sort of blocked these by adding this .txt so that the Aiken check and everything didn't mess with it. This Oracle uh, .ak was the one that we were working with. Um, so let's work with this one in this. I'm not going to need the terminal. We can close this down a little bit. Um, oh, does the outline work? Dang it, the outline doesn't work. I love this outline feature. It's so cool, but it's not working. Can close that down. Okay. So import inputs. Let's go back to the Fig Jam. This one I'm going to close, and I learned that center mouse wheel click deletes a tab in this browser. Um, okay. So this is a generic transaction. And let's orient ourselves to this. And I'll talk to Lewis here because he might be the one to understand this. Um, let's make a little arrow.
Okay.
So these are, oh, so this is the flow of a transaction. So inputs, and inputs are UTXOs, uh, and then it goes into a transaction,
So
which is,
technically,
yeah.
input, inputs and outputs go into the transaction. Transaction is a big body. If you look down below,
Oh, yeah.
if you look at this guy, you see inputs in there and you see outputs in there. Both of them are a list of sections, like both of them are two fields with lists in them, right? Technically,
Right.
you are putting the input UTXOs in there, you're putting the output UTXOs in there, and then you're submitting it to the blockchain. Okay. And the
Ooh,
blockchain analyzes this, consumes the inputs, and creates the outputs.
interesting. Okay. Yeah, where does the blockchain fit?
So, this
Interesting.
transaction body, after you build it, you submit it to the blockchain. You sign and submit it to the blockchain.
Right. And it gets all that gets translated into the CBOR.
Correct.
Mhm.
Interesting. Interesting.
So
Okay.
the blockchain comes in when you're doing the transaction part, right? So input UTXO and then transaction and then output UTXO. So the transaction is where the blockchain comes in. The validator part. I'm looking at this diagram on top.
Mm-hmm.
Yeah.
The arrows. Yeah, that one, transaction name validator. That's why the blockchain comes in between.
Not in between. The
Oh, okay.
transaction
It's
is,
funny.
so what we are doing, like that's why this arrow is technically
Yeah.
like this.
Yeah. Yeah.
Why is it
Ooh,
technically
let's.
like this? Because we are just building the transaction. Once we build the transaction, what happens is, you see this transaction object? These are all
Mm-hmm.
fields in it. These fields will get populated, like all necessary fields will get populated. And then we submit this, we convert this into a CBOR, and then we submit this transaction object to the blockchain for it to approve or deny.
Okay. Approve or deny. Okay.
Yeah.
Yeah. I can't grab this. I can't grab this guy. Here. Here we go. Okay. So I'm just gonna, we'll just mess around. So it goes to this, and then we get CBOR.
So first, okay, so if you really want to break it down, first we create the unsigned version, then we sign it, all the necessary signatures, and then, I mean, I guess like, yeah, you can convert it to like a unsigned CBOR as well, yeah. And then you can sign
Oh,
it. Yeah.
but that's good. Yeah, let's put those sign. Hey, we're just messing around here. We're just messing around here. Um, unsigned, and then it makes another one. So where do the wallets come in? Like, because when I think of signed and unsigned, I think of wallets.
Yeah. So wallet is just a UI that provides access to addresses and signatures and stuff like that.
Okay. Yes, exactly. Exactly. Wallet is just a UI. That's a good quote. Yeah, again, this is sort of changing our mental diagram or internal way of seeing it. For instance, now if you allow me, let's zoom back and like the idea that inputs and output UTXOs come into the transaction and then uh output
We just build
transactions.
the transactions with the input UTXs and output. They don't necessarily come in, like, we are just building it.
Right.
We are putting it in, yeah.
Right. But I'm just thinking in terms of this guy, and this might be the way, like they're not, well, this ship state UTXO is an output, but also an input, right?
Correct. That's right, right? Like
Yeah.
UTXOs are consumed and UTXOs are created.
Interesting. So that might be a better way to think about it. Not input UTXOs, but consumed UTXO and created UTXO. Is that a
So,
better way to say
so
it?
that is semi-correct only because there are reference UTXOs. Reference UTXOs are input UTXOs that we do not consume. We just like
Ah,
read information from it, or we
exactly.
just like get
Okay.
information from it.
Would it make sense to have um would it make sense to distinguish between consumable UTXOs and reference?
Yes, if you add reference UTXOs to the first box,
Okay.
it makes perfect sense.
Okay. Because I feel like we're going to have a reference UTXO in this
So if you
next.
see the transaction object, if you see the second field, it has reference inputs.
So, ooh, nice. Did you just do that? How did you do that? You waved your
No, you
hand?
just like
That's
move
very,
it and then it becomes a hand.
oh my God, that's awesome. Okay. Okay. That was me distracting us. So perhaps to get closer to, oh yeah, Lewis is doing it too. Um, perhaps to get closer to the developer mindset, we could put uh we could change this to not consumed UTXOs and reference UTXOs. We could say inputs, reference inputs, outputs. Would it make sense to put all of these in there? Which are the ones that are uh absolutely required?
That really depends. No, what are you trying to do?
Yeah. Are there any that are optional that just, you like, for instance, treasury donation, uh votes? I imagine, like for instance, let's go over to our code right now and let's actually I'm going to zoom out and I'm going to create this.
Okay.
I'm going to duplicate this and we are going to make the transaction for our oracle.ak file. And I want to look. Oh crap, I made it go away. Um, because in the Asteria, I did quite a bit of work on visualizing this. I'm going to go for it. Hold on. I'm going to go for it.
So when do we jump into Oracle AK, Oracle NFT, like the actual ones we need to build today?
Yeah, that's what I was just because I was just going to go and look at how I visualize the oracles in the Asteria. This is all I did. They had like a kind of a um, documentation, like a written English of what the AK files had. They had uh, validator, redeemer, 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 and they had params for the validator, and they had some description of what the redeemers did. Okay. I'm just looking really quick as to how I did this before, and it looks like it was nothing. Okay. It was a big nothing burger. Okay, so let's go to I want to go first before we go back to the code. I want to go back to the mesh documentation and try to get a big picture of what's going on here. And I'm going to look at this side on the left. It's not helping. Quick start contract logic, Oracle token, Oracle data minting policy, setup, mint an Oracle token, first mint, second mint, so on. So basically, which part, like how does that Oracle AK, and I'm just going to make a look at it here. How does it fit in with this application flow? Inputs at with policy. When
Eat all the eggs.
spend and there's a min NFT and a
So in
stop at
general, I have a
Oracle.
small question.
Yeah,
So
okay.
what is a validator? So what does the validator say, for example, in a specific transaction, we're interacting with the validator.
Yeah.
So what exactly does the validator have access to, and what is it checking? Like, different validators check for different things, but what is the whole thing that it has access to, that it checks within?
Well, I would think these parameters these are the things that it has access to.
Yes, correct.
And
So,
this,
uh-huh.
and then it's interesting because this transaction is the transaction that it's coming in on, or where that triggers it, I guess I should say. So it has access to itself in a weird way. Um, uh, and then the redeemer is hmm, so the redeemer is in.
Yeah, where do you think we get the redeemer from? So, for example, there is datum optional redeemer input, which is output reference. Where are they all coming from? What does it like? Who gives all of this to the validator?
Okay, that's a good question.
Yeah, that's a really
The,
good one.
what you have an idea, Lewis? You want to jump in on that one? Because I think
Mm,
the the trans the datum comes in the transaction. The redeemer seems like the redeemer is this I mean, like this is the redeemer. Wait a minute, wait a minute, wait a
Do
minute.
you want to go back to the go back to the whiteboard once?
Okay, here we go.
so I just Googled it. I was like, okay.
Oh man.
Go look at the transaction object. There is a section called redeemers.
Mm, uh-huh.
Okay. And what are the other
Redeemers.
things? There's a section called datums.
Oh,
Okay.
Yeah.
So basically, whatever information it gets is already inside the transaction. We cannot give it external information because the validator is on the blockchain, right? And a blockchain can only access a transaction. You cannot give it random
Validator.
external information unless you're sending it as parameters, which is something we put on the blockchain beforehand. Like,
Mm.
pre-transaction parameters. Does that make sense?
Okay.
So you're saying we input the parameters
So,
before
do you
it's
know which
submitted
parameters
onto
I'm
the
talking
blockchain?
about?
The 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 spend transaction what
No,
input?
the
Mm.
spend stuff, the mint stuff, it's all transaction parameters. Pre-transaction
Mm.
parameters are when you are creating the validator, you input some parameters. You can input some parameters, it's optional.
Mm-hmm.
Um, so those are the ones you can put beforehand when you are creating the validator. But the rest of these guys are all during transaction. So that means all of these values have to be inside the transaction.
Okay.
Newman is deep in thought. What's going on?
Yes, I'm
You
on camera. You guys are like, what? My head was spinning. I it it it's so interesting. Like it has to do with the mental model. And because this is the mental model that this is a really basic schematic. And it doesn't provide a lot of the information, but it does some. Does it hurt? Is it something that you have to backtrack? Remember, we talked about the wallet, the idea of a wallet, and you're like, actually, the wallet isn't a thing. That's all just output reference. It's all just, like it's just a wallet is just a parameter on a UTXO. And, the stuff in your wallet are a bunch of UTXOs that have the same, address parameter or signature parameter. So it's like my mental model is shifting, and I want to get to one that has a real that's good and makes sense. That's not overly complicated. Um, but it's something that I can use. And again, it's something that I can use to visualize and communicate these transactions, these uh, intents. I've heard it called intent. Like, okay, my
Mhm.
intention for this application, for this service or this thing, for instance, in this one, it's an NFT minting machine that, enumerates a next, you know, like it creates an NFT with this datum that increases. Um, yeah, so that's what I was thinking on, and it does make more and more sense the more and more you work with it, even though your mental model may be outdated or incomplete. Um,
Yeah, and
so
I
yeah,
want to like go into one specific field of the transaction, which is the redeemers field.
okay,
Okay. If you look at the redeemers field, it has a bunch of pairs. Okay. A pair is nothing but like two values, right?
right,
And each of these values has a script purpose and its associated redeemer. And there are
okay,
multiple pairs that can be there. There can be multiple script purposes and associated redeemers. Okay.
okay, sure.
And these are this is how one transaction can basically interact with multiple validators and their redeemers and their associated redeemers. Does that
Be,
make sense?
because one transaction can interact with multiple validators. Be, uh, uh-uh.
So
It
when
doesn't
you're
make sense.
interacting with a validator, what you're actually doing is you're interacting with their script purposes. So a
Yes.
validator, think of a validator that has like a spending script purpose and a minting script purpose. Okay.
Yep, yep,
So now that validator, you don't like directly interact with the whole validator. You interact with that specific script purpose plus
right.
its associated redeemer.
Oh, wait a minute.
So that becomes a
Because,
little pair.
right. So how, so now I'm thinking that because again, it's a mental model thing that like a transaction or a validator. So what exactly is a transaction? That's what I'm, I mean, it just sounds so silly to say. Because if we, if we're inputting redeemers, let's change this up. So we want like all of these are in, let's make this back into input UTXOs, or I don't know. Hold on. I think we need, it might help to get like, it might help to just look at a transaction at this point and see it with this new sort of visualization. Um, yeah. Hmm.
How do you mean look at a transaction and see it with
Like
vision? Like,
let's create a transaction and go through like
and go through
I
each
think
of
I'm
the
bait for
fields.
lock.
There is a problem with that. Do you know what the problem is? That
Uh
it becomes like it's actually like very, very opaque, you
yeah,
know? So we even if you like do that and you basically want to see, oh, print transaction, and then it shows all the fields and all the values inside it, correct?
yeah.
It is actually like
Do it.
quite opaque. I can show you an example. When you get the CBOR, if you get a CBOR in a transaction, I can show you the example. Can I share my screen for just 1 second?
Sure.
Um,
No. What if you said no?
Absolutely not. I'm sorry. That's just too much. That's too much.
yeah, so say for example, I'm going to sign this transaction, okay?
Okay.
This is just
Wait,
a
well,
random transaction.
it's a random transaction. Okay.
Yeah, so I
So here's a
am,
mesh.
yeah, this is just like some mesh and I'm just going to sign it. Um,
Okay, so you're running the front end. You're going to do it on the front end. So you're looking up the
yeah,
local host.
yeah. And I will connect my wallet
Okay.
and I will do this.
So you clicked on that link that creates a transaction. So now, wait a minute, pause for a second. Well, okay. So you
Uh,
could download that unsigned, which is an unsigned CBOR, which wouldn't make too much sense to us.
does it already show the unsigned CBOR? Let me see.
I just
Console.
in that signing screen, there's an ability
Yeah,
to
here.
download.
Yeah. In the signing screen, is there like an unsigned CBOR? Where is it? Oh, download unsigned. Yes.
Oh,
Okay. So
Pretty cool, huh?
now I got it out. I'm gonna copy this guy. Where is the unsigned CBOR? Oh, here it is. This is the unsigned CBOR. Okay.
Okay.
I am going to go to, this is just for you to see what it would look like.
Right. So you're gonna
Seek,
transcribe. Yeah, yeah.
Sequisitor.
Sequence. Okay.
Okay. This is just one of the ways of doing this. I'm going to put it here, and this is what you'll see. Are you able to see this?
Yeah,
yes.
yeah, yeah.
So this is your
Oh,
transaction basically before signing. How do I know that? Transaction hash, because there will be the signing part will be empty. Where is the
uh-huh.
signing?
B keys right there, right? Witness set.
Where is that? Oh, yeah, witness set. Where is that? Oh, yeah, right here. So
Yeah,
this
okay,
is
okay.
empty. Nil, null, 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 null. You see this?
Okay. Yeah.
Uh, Witness
Well,
set.
hold on. Let's bring up the transaction. So our inputs there.
Yes,
Auxiliary
all
data
of them will be
body.
there. 1 second. So, auxiliary data, 4 items, metadata, native scripts, Pluto scripts, prefer blah, blah, blah. Auxiliary data hash, collateral, collateral return,
Inputs.
inputs.
There
Oh,
it
here
is.
it is.
Fees.
Inputs.
Interesting. It looks like inputs are underneath fees, but that's not true. But fee is
It doesn't,
one, so we got
do you realize
fee.
like that doesn't matter?
Doesn't
Like,
matter. It's just wherever it goes, right?
yeah, yeah.
And donation there. That's in the transaction. Let's, so there are two inputs. Mint has a value. This is null. Network ID. There's a thing called a transaction uh, ID or just ID. Reference inputs.
It's all null because I didn't interact with any validators.
Okay, that's got it. Script signers. Is that extra signatories? Is there anything called
That is the witness set as far as I know.
yeah,
Because it has like a list of V keys, right?
yeah, which would be
The signatures.
maybe yes. Yeah. I wonder why it's just extra signatories. I think that's strange.
Yeah, extra signatories and witness set is like the same thing, I think, as far as I know.
Similar. Okay.
Yeah,
It's a list of verification key hash.
yeah, V keys.
Yeah. Is that the only spot where redeemers are
Yeah.
in the verification? Interesting. The redeemers are kind of like witness sets or kind of like a key because they are the ones that stop transactions. And that's the
Wait, what do you mean they're the ones that stop transactions?
they are the ones that like allow or disallow a transaction. You know, like if it doesn't match the
No, it's the
redeemer in the
no, no. I mean,
a little
it's a
bit.
little more nuanced than that. Like, uh, th- I, I don't understand why you would say redeemers would stop the transaction.
Well, they
Um,
are the things, they are the in the AK file, they're the thing that says, okay, it has to be in this time range, it has to have this signature, it
no,
has to
no, no, no,
have
no. Redeemers don't say that because validity range is a whole other section, right? In the transaction.
yeah,
If you look at the transaction, if you look at this, validity range is a whole other section right here.
yeah. But like look at
Okay.
the AK file. Do you have the Oracle AK? Or do you have the
I don't have
or
the
use
Oracle.
or
I
in
can
your just
yeah, I'll go to
any
mesh.
yeah.
Yeah, and where do I go, Newman?
Resources, full course.
Full course.
Yeah.
Uh,
And then
Resources, full course,
down to lesson 8. So if you
lesson
scroll lesson
8.
8,
Okay,
Plutus
Plutus
NFT
NFT
come.
contract. Okay.
Okay, and then scroll down to
This is the Oracle
the
NFT policy.
yeah, there should be a link to the AK file. Oh, there it is, right
This is
there.
the one, right?
There it
Okay.
is, right
Yeah,
there.
yeah.
Yeah.
Yeah. What are you saying in this? Let me
So
make this bigger so you guys can 1 second.
fair enough.
Okay.
Okay,
Yeah.
good. So scrolling down, so there's our spend, our validator called Oracle, and the spend purpose or the spend purpose.
Yeah.
And then it says is when the redeem. So those are the two redeemers that it is Mint Plutus NFT and
Mm-hmm.
Stop Oracle. Those are the two redeemer types.
Okay.
Um, so this redeemer type is kind of like a key, like an agent, a person. It's just like, will I sign this or not? This is just my mental model of how I'm thinking of it. So when it,
So think of it as like branches. Okay.
okay,
So both Mint Plutus NFT and Stop Oracle are still spending a UTXO.
okay,
Okay.
yeah, yeah,
They're both spending a UTXO. But if you give the Mint Plutus NFT redeemer,
yeah,
it is expecting this logic.
right, 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 right,
But if you give the Stop Oracle redeemer, it is expecting this logic. So
yeah,
it's
yeah.
basically just like branching things. Like you are basically saying, hey, this redeemer is associated with this logic. Now, if this redeemer is this logic, this part of the logic has to be satisfied for the transaction to go through.
Okay.
Right. And that's I guess there's a fundamental logic in a transaction that says if the signer isn't correct, then don't do it. Um
Correct.
or
Yeah.
in my from my limited sort of,
No, but
mindset
it
here.
says this is owner signed. Like if the owner is signed and if the logic says is the owner signed, then it'll it'll pass or not pass depending on what that even means. Is owner signed? They're basically going to the what is that extra
Yeah,
signatories and
extra
checking if the
signatories.
owner's wiki is in that.
Yeah, yeah, there you go. Yeah. So you could create a redeemer that's not it could, it will spend anybody that asks to spend, it'll spend. Um, so that's not necessarily,
So
yeah, yeah.
think of the
Okay.
redeemer as like an identifier. That's it.
Okay.
That's it. So this
Mm.
redeemer is associated with this part of the logic, and now you have to satisfy this part of the logic. So say for example in this, right? If we give both of these, this one and this one, right? So that means
Yeah.
this part of the logic has to satisfy, this part of the logic has to satisfy, but
Right.
the transaction will fail. Why? Because there's this part of the logic, it does something, and this part of the logic does something, but they don't go together. If you do this, you cannot do this. You know what I'm saying?
Yeah. Right, 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 right. It has to be one of these flows,
Yeah,
they're
in this
exclusive.
case, because these
Yeah.
two logical blocks
Oh,
basically collide. But if they
but
don't
if
collide, you
you
can totally do it.
right, so but if you scroll up a little bit, just
Mm.
before that, they've got
Mhm.
like general logic. So
Yes, this is just
inputs
like
this,
general. Yeah.
yeah,
This is
I
Wow.
not
guess
even
all of
logic,
that.
basically. They're just like getting some values out. Is there like a extract? Yeah, they haven't performed any logic. They're basically getting all the necessary values out of the transaction. That's all they're doing up until here. The logic starts inside here, these guys. This
Well,
is
I'm
where
thinking
the
about
real
that
logic starts.
when I'm thinking about
Yeah.
that when block because we talked about
When
that
block.
one
Yeah. Yeah. When
like
is. It's
yeah,
just when is block.
the when is block, yeah. And
Yeah.
so typically, yeah, yeah. I remember we looked at this one as because it's a typical or you can see it where there's nothing in the when section. It just says when is. So it's sort of like not making a distinction. But the
How do you mean? Like, as
this
in?
as in there's another check, there's another gate that says it has to the way I understand it is it has to have some redeemer, meaning that there has to be a redeemer, and then these two checks, inputs at with policy and outputs at with policy. So
Yeah,
and those are I think are mocked or cocktail functions that
yeah.
basically check that the Oracle NFT policy has an input and output, that this Oracle NFT policy or Oracle NFT goes with the
So, there's
build out.
another way to write this. It's
Okay.
a more complicated way, but there's another way to write this. I can totally remove these two guys from here, the inputs at with policy and outputs
Uh-huh.
at with policy, and just say when redeemer is mint Plutus NFT, then perform some logic. But
Right.
inside that logic, I'll have to do these.
Yeah.
I'll have to
Yeah.
check for inputs at with policy and put it inside that logic block. So
Yeah.
they have just like made this an easier way of doing it. They have like, you know,
Yeah, they factored out that bit of logic
exactly,
because that
exactly,
logic
exactly.
happens for all redeemers. Yeah, 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 yeah.
And
Or for the redeemers that are there, those two
yeah, yeah,
redeemers.
yeah, exactly, yeah.
All right, all right.
And now are you getting like a better understanding of what a validator is, what a transaction is, what is the transaction object, how they all
Well,
interact?
yeah, I mean, yes, I mean it is a thing about like these community code reviews that we drill down and find the thing that we most uh don't understand or something. But I'm hoping to get, and I'm going to work on this through the week because I do want to start landing the plane and not go too deep this week. I want to go back to the uh like I want to get the whole picture. And I feel like we can continue to work with this vesting contract, or not vesting contract, this
So do
Plutus
you, how
NFT
much
contract.
time is, oh, we're almost, so we have about like 20
15 minutes
minutes
left.
left,
Yeah,
15, 20
yeah,
minutes left, right?
yeah.
Let's
So
try
we
to
could,
do this. Yeah. Mhm.
yeah, yeah, go for it.
Let's try to just like create a mental picture of what's going on, right?
Yeah,
They have given us like a lot of prerequisites, key concepts, what's a Plutus NFT, is a smart contract, blah, 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 Oracle NFT. One-time minting policy for the state thread token.
yeah,
Oracle Validator holds and updates the current NFT index. Okay, one time. So this is like a token. You just like mint Oracle NFT. And this validator is a spend validator that holds this NFT, Oracle NFT, in one UTXO. And then the Plutus NFT. This is the NFT that the users mint.
yeah.
Make sense?
So yeah, now let's look at this little
Mm-hmm.
graphic. Yeah, because an Oracle NFT, the one in the middle, that's the one that we were working with so
Correct.
much.
Yes. Yes.
Or Oracle Validator, not Oracle NFT, the one in the middle. So that first one that creates the state thread token
Yeah.
or the Oracle
Let's
NFT.
do this. Let me quickly create this. What I will do is, so there's a little box. This is mm, this is
Or Oracle NFT, the first one. Yeah.
yeah, Oracle NFT. So I haven't even looked at the validator, but I know that it's a mint validator. Okay. Why do I say
Yeah.
it's a mint? Because it's just minting an Oracle NFT. Now, just to
Okay.
confirm that, let's look at the Oracle NFT policy. Is it a mint validator? Oracle NFT is a mint validator. You see that?
Right, 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 right.
Mint's purpose. And it has the logic. When can you mint? And so it's not, yeah, it is a mint and burn. But yeah,
Burn, yeah,
so
yeah.
Okay.
for one redeemer, it is like R mint. For the other one is R burn.
Yep.
But both of them are minting. And when you say mint, do you know which part of the transaction you see the mint in? if you
Well, it
go
is
back
a part.
here,
Yeah, right
look
there. Yeah,
here, you see the mint.
yeah.
When you mint
Uh,
or burn something, this is
you
where
need a
it shows up.
yeah,
Okay.
and it just requires a value. So, and I know
Uh,
that
y-
a bird is
so
actually a mint with a -1, right?
correct. And value is not just like integers, by the way.
Mm-hmm.
Value,
Mm-hmm.
when it comes to the blockchain, is slightly different. It is
Yeah.
basically a policy ID, name of that token, and the amount of that token.
Yep. Yep. Yep.
Okay.
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 If you want to quickly take a look at,
Yeah, I'll bring it up. I'll bring it up. Aiken Lang standard
yeah,
lib.
you can paste value in the in
I'm going
our
to put value right there.
yeah.
Exactly.
Okay.
Exactly. And it's a Cardano asset. No, wait a minute. Which value is it? Um, collection pair. Aiken collection. I got it. I got it.
Yeah, yeah, that's good.
Mint. And then, oh, yeah.
Okay. It contains policy ID and asset name. Is that right?
Okay. So, and you already put it there? You're
No, no,
looking
no.
it
I'm
up?
grabbing it right. I'm looking it up right now. Let me grab it. Get it here. Got it right here. And copy and bringing it in and value. Okay.
There you go. Value. Value, a multi-asset output value contains token indexed by policy ID and asset name.
Yeah.
And the number in and the number of tokens as well. Okay?
Yeah.
Makes sense?
Okay. It makes sense. Makes sense.
Okay. So now we know that with the Oracle NFT, you just like mint an Oracle NFT. Step 2, let's look at step 2, what is happening. How one-time minting works, UTXO reference parameter points to a specific UTXO, blah, blah, blah. Arbon, okay, anyway. So we have activated, so for now, assume we have activated our mint, which is one of the redeemers that it provides,
Yeah.
and we minted the NFT token, okay? Now, what we'll be doing is we'll be discussing the main one, oracle.ak,
Yep. And it's a
okay? And what is
spend.
this? It is
Yeah.
a
Spend.
spending validator, correct?
Okay.
Yep.
So a minting validator, the main artifact it provides you is a policy ID.
Policy ID.
Okay.
Mm.
Similarly, a spending validator, what is the main artifact it gives you?
Uh, well, it's gonna consume a UTXO and it's gonna I mean, just because I know that we've looked through it, so it's gonna have an input and an output.
That is
Um,
literally like everything, right? But
Policy
yeah.
a
ID and
spending
then
validator creates a validator address. Why does it create a validator address?
Oh, okay, yeah. So that it can be a reference UTXO.
No, not a reference. Again,
Oh, no, no,
what do
no.
you mean reference UTXO?
So it's so that you can send the transaction to that address. No,
No, no,
you
no.
can
The
send the
transaction you're
UTXO.
only sending to the blockchain. The blockchain is a ledger.
Yeah,
Mhm.
Okay. The blockchain evaluates a transaction. But Oracle.ak creates an address because you can put a UTXO inside this address.
yes,
Okay.
that's it. That's it. Yeah.
And if you want to spend that UTXO, it has to follow the logic inside the Oracle.ak. Okay.
Absolutely. So full stop. Like that in the middle model like is super helpful. So this Oracle.ak, a spending validator, creates a validator address where a UTXO is connected.
No, UTXO is basically stored. Like you can think of it as like it is stored.
It's stored there.
Stored
It's stored
in
there.
an address. And
It's
to
stored in
spend
the
that
address.
validator, sorry, to spend that UTXO, you need to
Follow this validator logic.
Oracle.ak
Yeah.
logic, right? Because
Yeah,
spend
yes.
validator.
Okay.
Okay. So now you have this Oracle NFT, right? So let me put this. Let me get this guy. Oh shit, what's that?
Sometimes it's hard to grab those. You have to zoom in on them. The arrows. If you want to
Yeah.
like copy the arrow, I'll grab it for you if you want. Get it.
Excel stored at this address, right?
Yeah. Yeah. I did the same thing.
UTXO is stored at this address, plus it holds the Oracle NFT that we just minted from here. Make sense?
Yeah. I'll try to fucking move this silly ass. Oh, okay, hold on. I've
No, don't worry about it. What you like?
I'm just talking about it. Here we go. I got
Yeah.
it.
No, focus. Like, let's get this done because
Yeah,
we have only 10 minutes left. Okay.
we got 10 minutes. Okay.
Yeah.
Okay. So we minted
Yeah.
an Oracle NFT using the Oracle NFT .ak validator.
Yep.
And we stored that Oracle NFT inside a UTXO, which in turn lies inside like a validator address from the
Yep.
Oracle.ak. Okay.
Yep.
So along with this Oracle NFT, this UTXO also holds datum.
Datum. Yeah. Okay. Yeah. Yep. Yep.
Okay. And this datum is the counter. If you
Yep.
go back, create Oracle, blah, 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 implement
Yeah. Yeah. There it is.
Where is the counter? Where is the
If you go up to the Redeemer type,
redeemer type?
scroll up. It's out of this. It shows it just above it right there. There you go.
Oh, okay.
Define the datum.
Oracle
There's the
datum. It
count.
has count, it has Lovelace price, and it has fee address.
Yeah.
So all of this is in this
yeah,
specific
please go.
UTXO, which exists in this validator address. Okay.
Yep.
And
This UTXO, let me say that out loud just so that I can get it in there. This datum is inside of this UTXO, which is stored in this Oracle validator address.
correct.
Okay.
Okay, I'm going to separate these guys only because this is like a separate thing and this is a separate
those
thing.
are separate.
Okay?
Yeah.
Now let's go to the final validator, which is what the users, I mean, the users will be interacting with both, but the Plutus NFT minting policy, okay, which is the Plutus underscore NFT.ak. Okay. And what do you think? Do you think this is a spend validator or a mint validator or what?
Yeah, this got to be mint, right?
Right. Yeah.
Because you're creating a new.
Yeah. We are making people mint a token. So it is a mint validator. Okay.
Yeah.
And remember, a validator doesn't just have to be a mint or just a spend. It can be a mix of everything. It can have a spend endpoint. It can have a mint endpoint. It can have like some other endpoint.
Yeah.
And each of these endpoints is associated with a specific redeemer. So we know that endpoint is being referred to. Okay. But so now this has like our burn and an R mint. So even with the Plutus NFT, we can either burn it or mint it. Okay. But to mint it, what is happening is, so now let's put another one here. This is like the Plutus NFT.
Yeah, Plutus.
NFT.ak, and it is a mint.
Mint, yeah.
Okay. So that means it will have a policy ID.
Okay.
Okay. Oh shit, where's this? Yeah, okay. So to be able to mint something from here, you also have to spend something from the oracle.ak and update it. Do you get how
Right.
both of these are connected?
Okay. They are connected by that Oracle NFT, um, which has the datum and it resides in this validator address. So so its input has to be Oracle NFT and its output has to be Oracle NFT back to that validator address.
Correct.
Or
Correct.
yeah, okay.
Not the Oracle NFT, but the Oracle UTX. So the whole UTX. Yeah, you're right.
Yeah, the Oracle,
Yeah,
yeah, because the
exactly.
UTXO is consumed and created, a new one is created, but it has to have that Oracle NFT in it.
Yeah, it has to have that updated datum and it has to still hold the Oracle NFT.
Right,
Okay.
right.
And so that is how these both are
Mhm.
connected. If I want to mint a Plutus NFT, I'll have to follow this logic, whatever this logic is in the Plutus NFT mint. Plus, I have to spend the Oracle UTXO, update it, and send it back to the address. Okay. So I'm basically updating the counter in the datum.
Okay.
Make sense? I'm
Yeah,
updating the
Yeah.
counter in the datum. Where is this count? I'm updating this guy in the datum.
yeah,
So
yeah.
every NFT that is minted, the count goes up. Every NFT that is burnt, the count goes down.
Yeah, makes sense.
Okay. And that is why it is called an oracle, because it keeps track of the state of number of Plutus NFTs being minted or burnt.
The the
So what is this
Oracle,
oracle?
yeah.
What is
Yeah, the
this
Oracle
UTXO
NFT, yeah.
doing? This UTXO is
Yep.
basically keeping track of the number of Plutus NFTs that are being minted or burnt, right?
Okay.
And
Okay.
that is why it's called an oracle.ak. That is why it's called an oracle.
Yep.
Okay.
Oh, yeah,
Does that
sure
make
enough.
sense?
Yeah, totally. From my understanding of what Oracle does, here's the.
Okay. So now I'm going to stop sharing and now you guys, one of you guys can share and like ask any questions that you have.
All right, let's see.
Wait, share what? Like share screen.
Just yeah.
Yeah, share,
Ah,
share. If you want, you guys can share your screen and ask questions. Do you have any questions? We only have 5 more minutes. So four more
Yeah, let's
minutes
go five more
actually.
minutes. Yeah,
Yeah.
we'll go for 5 minutes.
yeah.
Let me Lewis, do you have any burning questions on, and otherwise I can share my screen.
No, I don't have any burning questions.
Okay, cool. All right, so let's go back to our Figma and zoom out here. Go like this. So this guy.
No, I didn't separate them because they're both
Oh.
working in the same transaction.
Oh, yeah. I got you. Um, so this, right, so here might be interesting to like make a transaction for this. Let's do this. And a transaction for this. So here is a transaction. And here's a transaction. Now this one is going to be called
Mint Oracle
Oracle.
NFT.
Well, yeah. Mint. And that's just in English.
Yeah.
And the validator is going to be Oracle NFT. No, just called
No,
Oracle.ak.
it's Oracle NFT. No. It is Oracle NFT because you are minting from the Oracle NFT.
Let's just go back. Yes, this first one. Yep. Yep. Mint and burn. Okay. Oracle. Is it or NF underscore? N NFT. Why do I keep wanting to say? Here we go. Okay. Is that right? No. And does it take, again, let's look at, does it take any, okay, well,
So to
actually,
understand that, you'll have to look at the validator.
right. Okay.
So if you want to mint, so it is a pretty straightforward one, right? If you want to mint, uh, it says has equal to function input let hash is equal to input output reference, UTXO reference is equal to hash. What is this hash? Oh, so it is taking like a UTXO reference. So that
Yeah.
means it is basically, yeah, no. If you look at the, even before the mint, when this validator is created, it is created with a parameter called
Uh,
the UTXO reference. Okay.
yeah. Yeah.
So do you know when they do this UTXO reference as a parameter? When you
When
want to,
it's
yeah.
right. When you want to use an existing NFT.
No, no.
No.
No. UTXO reference is a reference to a UTXO. It's the name of a
Okay.
UTXO, right?
Right. Not an NFT, not a policy ID and
Yeah, exactly. It is a UTXO.
okay.
Okay.
So if you want to enforce creating an
Uh-huh.
NFT, what is the difference between an NFT and a random fungible token?
Uh they have their own policy IDs.
Difference, I said, not similarity.
They oh uh well they have a unique value or index. Yeah,
Fungible
what?
tokens are tokens that many identical ones
Yeah,
can exist. An
right.
NFT can only be one. There can never be
Right.
another. That's the whole point of an NFT. If a similar
Right.
NFT is created, then it's not an NFT anymore. Correct?
And then how are they distinguished? It's not date. Is it datum? What's
No. So it's literally their existence. If only one Newman exists, you are an NFT. But if multiple exactly same copies of Newman exist, you're no more an NFT, you are a fungible token.
you're blowing my mind.
Okay?
But how is where is the difference in the where is the difference in the? It's
There's no
not in the.
difference. There's no
Oh.
difference. It is the difference exists in the fact that either one exists or multiple exists. That's it.
Oh. Okay. Oh. Okay.
But sometimes we can enforce that only one exists, and that is what I'm trying to show
I
you here.
see. All right.
You
All
know,
right.
so for
Yeah.
example, here in the validator Oracle NFT, it is taking a parameter of a UTXO, right? And a UTXO can be spent exactly once. You cannot spend a UTXO more than once.
Right.
Okay. So if
Uh,
you mint
Yeah.
a token, exactly one token, by spending one specific UTXO, you can never recreate a similar token again because the UTXO is spent.
yeah.
Does it? No, that doesn't, that didn't hit, right?
Maybe it didn't. I know this trick. I've come across this before. That is it's part of the SIP or something.
Um,
That's oh shit. I don't know.
No, just look
Uh,
at this R mint. Like this is a very small. Okay. Let's close with the R mint today. Okay, just minting
okay,
like this
sure.
Oracle NFT. Okay,
Yeah, you gotta
and
share
now
the
we
screen.
have access to a UTXO, which is UTXO reference output reference. Correct?
Yeah.
Just based on the parameter.
This.
Now
Yeah.
going inside the R mint, you are accessing the inputs field from the transaction.
Right.
Okay,
Right here.
and it is saying let hash
Yeah.
equal. Hash equal is some random variable we are creating,
Yep.
which is equal to uh, there is a function that takes the input, okay, and let hash equal to input dot output reference.
Oh, I got it. Yeah.
I'm trying to understand what this function is. Function takes input of the type input and at the inside it they're creating a variable called hash, which is equal to input dot output reference. So hash is an output reference.
Mhm.
And okay. So
So
um
this UTXO reference here, this output reference has to equal this output reference. So
correct. So hash
this is
equal,
the yeah,
uh,
yeah.
hash equal is a function, by the way.
Hash equal this guy. Yeah.
Yeah,
Yeah.
hash equal, they're defining a function. Hash equal is the name of the function, and this is what the
Yeah.
function does. It
Yeah.
takes an input and it
Yeah.
compares it to the UTXO reference that we have from the parameter, and it just
Yeah.
compares it. Okay, so
Yep.
it's a boolean. This is a function that gives out a boolean. In the
Love it.
next line, which is 25, let
Mhm.
target input exist is equal to list.find.
Oh, okay. Oh, okay.
List
Yeah,
dot
like yeah.
yeah, inputs comma hash equal, because remember list.find, you
Mm-hmm.
find a specific input that satisfies the condition of a function that we provide, and the function that we provided is hash equal.
Yep, this guy.
Exactly.
Yep.
uh so
And
basically we are checking
if
if
they match, it's just a matching function.
it's just a
It
matching
says,
function that basically checks, are we spending this specific UTXO in this transaction? That's all we are
yeah,
checking. If
yeah,
we spent that UTXO in this transaction to mint this token cannot ever be minted again
right.
because we have already
Okay.
spent a UTXO. Once a UTXO is spent, it can never be respent.
I love it, man. I love it.
Say that again,
Um,
Hasha. Once this what?
So a UTXO can only
Uh-huh.
ever be spent once.
Okay, yeah, yeah.
Okay. And if you are referencing that UTXO when you are minting this token, you
Mhm.
can only ever do it once. You can only ever mint this token once because that UTXO has been spent after this transaction.
All right, makes sense, makes sense.
so I love it. Thank this was actually really, really good.
Yeah.
One of the things that I love about it is that we've got, you know, I think it might be really um good for learning to go through and actually make the front ends here, and then
Mm,
you can see it and you can go through this. So I think that might be a fun um like task or activity to go through and make this just basically follow along with this documentation and this tutorial. We started in the middle because we're sort of advanced, but I think we should be able to get it. And then maybe next week we come back and just keep going on this. We can
Yeah, do you
fill
guys want
out.
to go on this, or do you guys want to jump into the Aiken course and like start doing the Aiken course?
So the Aiken course would be good. We could do that. I feel like I want to at least one more week on this because I think that I really want to get to know the mesh code and see
So the
how it.
mesh code, that's what I'm saying. So the mesh code, let's do it in the mesh live coding.
Oh, we could do that in the live coding there. Yeah, that would be cool. Unfortunately, I've got schedule conflicts for the Tuesdays, which is a bit drag, but I can follow along on the videos. Um, that would be cool if you wanted to next week do this this example.
So what
That
I'll
would
do
be
is
kind of
maybe
fun.
not next week, because next week Andrew or Emmanuel will be doing the lesson, will be taking the lead.
Yeah,
But whenever I do it, I'll pick up this so that you can like take a look at it.
beautiful, beautiful. All
I
right,
really
y'all.
need to
Thanks.
start
That was a
joining
great.
this
All
Yeah.
right.
mesh
Thanks,
sessions.
man.
Yeah.